Okay, so yeah, that's what happens when you're not used to using QuickTime. I meant to pause and it just stopped. So here's part two of the recording. So I had this right now. In hindsight, I don't even think I needed to multiply by the inverse on both sides. I'll show you a different solution. So 0 star x, since this is identity, 0 star x is itself. X inverse star 1, I use the formula for inverse to set up this using the binary operator definition. Now at this point, I'm dealing with just a simple algebraic equation. X equals negative x over 1 minus x plus 1 plus x over 1 minus x. Oh, this is convenient. Destroy x equals 1. Another way I guess we could have done this is we could have just gone directly here. This might work. Let's see. This would be x plus x minus x squared. So this is a problem. I'll put problem here because we know that x can't be 1. So this becomes just a direct quadratic. Yeah, this becomes just a direct quadratic. So we have 0 equals x squared minus 2x plus 1. Oh no, this is not a problem. We get the same solution both ways. This is not a problem. I'm mistaken. 1 is just the only number that doesn't have an inverse. But 1 does satisfy this equation. So there's your solution. This is a 15-mark part. It took us under 15 minutes to do this, but you've got to know what you're doing to be able to correctly and sufficiently provide your arguments. There is a part B to this question. The domain of star is now reduced to these numbers. So we're going from being defined on the reals to being defined on 0, 2, 3, 4, 5, 6. Keep in mind 1 has been left out. Take a guess why. We're probably going to show that this is a group, and we already showed that 1 doesn't have an inverse. Arithmetic is carried out modulo 7. What that means is your results will be in mod 7. So now it's A star B equals A plus B minus AB in mod 7. All right. Copy and complete the following Cayley table. So 3 star 2 is the sum minus the product in mod 7. So this is negative 1, and in mod 7 this is 6. 3 star 3 is going to be the sum minus the product in mod 7, which is going to be, this is negative 3, this is 4. 3 star 4, sum minus product in mod 7, this is 2. This is 3 star 5, it's going to be sum minus product, that's 0. And then sum minus product, this is going to be 5. It looks like we have some commutativity here. We could try and prove commutativity and then just copy. Yeah, that'd be quick. So I'll say that A star B equals A plus, it'll be faster than doing all these computations. B star A equals B plus A minus BA, which is equal to A star B. So we do have commutativity. So I know I have reflection across the main diagonal. So this is 5, 5, 4. This will be a 5. This is 6, 4, 2. So this will be 2, 4, 6. I've got 3, 0. I don't know what that is, but I know this will be 0, 3. I've got a 5 here. I've got a 5 here. So we don't have to do too many more. 4 star 4 is going to be the sum minus the product. And that's going to be 6. 5 star 5, or sorry, 4 star 5 is the sum minus the product. That's negative 11. That's 3. And then we've got, so here's a little kind of cheat. We are going to show that this is a group, meaning it is a group. So that means this has to be a Latin square. So all the numbers have to appear in this row. The only number missing is 0. So there'll be a 0 here, a 0 here due to the reflection. This is a 3. We'll do 5 star 5. It's going to be the sum minus the product. That's going to be 6. Latin square property, this is 2. This is 2. Latin square property, this is 4. Let's just verify. 6 star 6 is the sum minus the product, negative 24, which is 4 in mod 7. So here's our Cayley table. We need to show this is a group. So we can say by the Cayley table, star S is closed. By part A, star is associative. It's associative. We proved that it was associative in all reals. This is a subset of the reals. So star is associative in R. Since S is a subset of R, and S is closed, star is associative in S. By A, the identity of star equals 0. And by A, all elements in R, all elements in the reals have inverse of the form negative A over 1 minus A not equal 1. Since 1 is not an element of S, all elements in S have an inverse. I'll say have an inverse. And then lastly, don't forget to write therefore S is a group, or S star is a group. A lot of writing in this option. Part 3, determine the order of each element. I definitely don't have space here for that. And then we need to state whether this is a cyclic group. Remember, a cyclic group is a group that has a generator. Alright, oh that stinks because I don't have all of my elements filled in. I'm just going to go ahead and fill them in. Try to do this quickly. 630, 624. Okay, doesn't want to write. There it is. Oh, nope. Nope. Alright, so 3, 0. This will be 6, 5, 5, 5, 6, 4, 3. Okay, so let me get the other elements. 4205. Alright, so we need to determine the order of every element. So I'll put X, and I put order of X. Make a little table here. So 0, the order of the identity is always 1. Remember, the order is the smallest positive integer such that when you raise the element to that power, you get the identity. Let's look at 2. 2 squared. So 2 to the first is 2. 2 squared, 2 star 2 is 0. So that's my order. Let's go to 3. 3 squared is 4. 3 cubed is 4 star 3, which is 2. 3 to the 4th is 2 star 3, which is 6. 3 to the 5th is going to be 6 star 3, which is 5. So it has to be 6. Since it's closed, we have to reach the identity now. 3 star 6 is 6 star, it's 5 star 3, which is 0. So this is order 6. This has order equal to the number of elements in the group. Order of element is equal to the order of the group. So this is a generator. At this point, we know that it's cyclic. So therefore, S star is cyclic. We need to find the rest of the orders. 4. So 4 squared, 4 star 4 is 6. 4 cubed is going to be 6 star 4, which is 0. All right, the order's 3. 5. 5 squared is 6. 5 cubed is 6 star 5, is 2. 5 to the 4th is 2 star 5, which is 4. 5 to the 5th is 4 star 5, which is 3. So this one's also going to be 6. That's another generator. And then 6. Let's hope this is painless. 6 squared is 4. 6 cubed is 4 star 6. Hey, that's 0. All right, 3. So we got all of our orders. We're good here. Almost done. Determine all the proper subgroups of S star and explain how your results illustrate Lagrange's theorem. All right. So Lagrange's theorem states that the order of an element is equal to the order of a group. States that the order of any element is a factor of the order of the group. So this is all elements have order that is factor of the group. Factor of order of group. In this case, our group has, I believe, 6 elements. 1, 2, 3, 4, 5, 6. Notice all of these numbers are factors of 6. So we have to list all possible subgroups. We know for a fact that the identity has to be in all of these groups. So I could throw in 2, and so that would be a subgroup, 0, 2. It'd be this little part of the Cayley table. Theorem of Lagrange supports that because both of these would be factors of the number of elements in the group. Oh, and I guess I should mention, proper subgroup means that it has less elements than the original group. So that means our proper subgroups cannot include the generators. Because if we included this element, which has order 6, there must be 6 elements in that set. But a proper subgroup would have less than 6 elements. So we're only going to have 2 proper subgroups. This one, and then the identity with the 2 elements that have order 3. Which I think were 6 and 4, yeah. We know that there are no other possible subgroups because we already mentioned why the generators can't be in the subgroup. There'd be too many elements, and the subgroups have to have fewer than 6 elements. But the reason we know we can't combine any of these is because the instant that I put 2 into my group, which has order 2, there would have to be a number of elements in the group that's a multiple of 2. So either 4, but there can't be 4 because there's no element of order 4 anyway, or 6, and that's too many. So these are the only 2 groups possible. Lastly, solve the equation 2 star x equals 5. We can do this with the Cayley table. 2 star x equals 5. I'm going to multiply both sides by the inverse of 2. And I'm going to find the inverse of 2 on the Cayley table. And I'm multiplying the inverse on the left. So technically there is, I guess, a 2 inverse 2 here. But they destroy and give us identity. So I'm going to go to my Cayley table. I'll find the inverse of 2. Here's 2. The inverse is the element which gives me identity when operated. It's itself. So it'll be 2 star 5. Which is going to be 7, 4. Let me just verify that on the Cayley table. Yeah. So I'm really trying to solve the equation x squared equals 4. So x star x, not x squared like normal multiplication. X star x equals 4. All right. So there's a tricky way we could do this, but I don't want to do that. Let's go ahead and write this out. This is going to be x plus x minus x squared equals 4. Remember, we're in mod 7. Actually, no, there's a faster way to do this. Just look on the Cayley table and look for which element operated with itself gives you 4. We'll do the algebra later just to verify we get the same thing. Just look along this main diagonal, because this main diagonal has x star x. So it looks like, oh goodness, there and here. So the solutions to that equation are 3 and 6. If we would have done the algebra, we would have ended up with 0 equals x squared minus 2x plus 4, which factors into 0 equals that's not good. So maybe this approach doesn't do us well. Yeah, that's bad. Oh, that's weird why that happened. So I'm not quite sure why algebraically we wouldn't be able to. Oh, I know why. Because we're in mod 7. So this may end up giving us a number that reduces to 4 under the mod. There should be a way to do this algebraically. I've got to think about this. In either case, the efficient method is once we get here, just look for an item on the Cayley table that when you star with itself gives you 4. All right, so it took us about 28 minutes, 29 minutes to do this with full explanations. So you've got to be able to work through this. Remember, your objective out of 60 marks is to try and get half of the test right. If you get half of the test right, you'll get a 4, and we can all move on. All right? I will see you on May 16th.